Alrighty, we're going to jump into chapter 3. We're skipping chapter 2. Chapter 2 mostly just talks about some computer methods that we can use to solve kinematics problems. We're gonna use specifically AutoCAD for a lot of problems that we do. I just don't feel the book does a very good job. One, just kind of tough to like look at that stuff in a book. Two, they don't really use the program how we're going to use it, and it's a little outdated. So we'll just jump right to chapter 3. But just know that you're kind of getting chapter 2, throughout the rest of the chapters as we work these problems. So, chapter 3 talks about vectors. This should be relatively straightforward. Your seniors, I fully expect you know what a vector is. We're going to go through it just to grease the skids, per se, and just make sure that you're well acquainted. We also will talk about in here, kind of starts to get you familiarized with how we're going to use vectors to solve kinematics problems, so I think it's worthwhile. So mechanism analysis, right, what we're doing in this class involves using a lot of manipulation of vector quantities, displacement, velocity, and acceleration, right? We all have magnitudes and directions, and all of these are vectors. So scalars and vectors, again, right, this should have been Physics 101. A scalar is a quantity that's sufficiently defined by simply stating a magnitude. So I guess we can do some highlighting. Scalar and magnitude, and a vector has a magnitude and a direction. So we're going to distinguish vector quantities by boldface type. This should be pretty straightforward. I'm pretty sure every engineer will do it with a boldface type. If I'm writing a vector, I'll generally, right, it's tough to kind of, I would have to scribble to make a bold V. So I'll just do a V with a line under it. Line under it is indicating boldface type. If we're looking at it graphically, though, we're going to see a line segment with an arrowhead. Again, right, indicating a direction. So one of the approaches that we're going to use is a graphical approach. And when we're looking at a graphical approach, especially as we start to get into solving kinematics problems using AutoCAD, this length, right, not just saying that it's 30 miles an hour, but this length itself becomes very important, that it is proportional to the rest of the lines that we draw, and that we are relating it to some reference axis, so we're pointing it and orienting it in the right direction. All of that actually becomes important, especially when we get onto the computer. So we're going to talk more about this graphical vector analysis. So a lot of times it's easiest to do this, right, so we can clearly visualize what's going on in a mechanism. And especially when we get to complex mechanisms, analytical calculations are going to become very laborious, and our final project will actually kind of showcase this. A graphical approach generally involves, right, drawing these scaled lines at specified angles, and we'll do this on the computer. You're not going to do this by hand. You might do a couple by hand, but we're going to do this on the computer. And accuracy of this, right, is our major objective. Again, we are going to use AutoCAD specifically for this. You can use SolidWorks for this. SolidWorks, at least for me, right, SolidWorks tends to be more of a 3D program, at least in my mind. That's how it was taught to me. I know you can do 2D, but AutoCAD was always the 2D program of choice. When I took kinematics, we used AutoCAD. And I prefer AutoCAD. I think it's just easier to have different layers in there to insinuate different points throughout a mechanism's motion, so we'll use AutoCAD. All right, 3.6. There's a lot of trig required. This should be no surprise. It's vectors. We're going to be turning them into triangles. What I've inserted in here is the trig cheat sheet. This, I believe this is in the top page of the kinematics course right at the top of the course in Moodle. I'm saying that now. I will check. If it's not, I will upload it in there. But this is very helpful. Use this on anything. Use this on an exam. Print it out. Keep it with you all the time. When I was in classes, I had this with me. I think I may have posted a derivative cheat sheet. I would print that one out too, and I would have it with me as well. These are very handy. I can't memorize all the relations of a right triangle, but this does a great job at summarizing and showing you how exactly to do stuff right. I'm never going to remember, the sum and distance formulas, the half angle formulas, but they come in very handy when we're solving problems. All right. Again, law of sines and cosines, we're going to use a lot of that. All right. So out of high school math and back to kinematics. So some vector manipulation, although I guess you could still call this physics 101. Again, right, as looking at this as far as mechanisms, we're going to be looking at manipulating vectors in different ways. One of these ways we're going to do is graphical vector addition, and you can see on this right side here, right, an actual snippet from AutoCAD, and what we're going to be doing is just write vector tip to tail, adds them together, and you get this resultant that we're going to call R. And that's how you add two vectors together. And if you scale them properly and orient them properly in AutoCAD, your resultant is correct. And we can do it analytically as well. There's still a little bit of this drawing out manipulation to get some angles for us. But if we can get this angle theta right, then we can actually solve for the resultant using our handy trig sheet, actually. And we can get the final answer. Last thing we'll look at is components of a vector, right? Remember, we can break a vector down into two components, right? Generally, our x and y. Here we're looking at h and v. So if we have this vector a, right, we can look at it as ah in the horizontal and av in the vertical, and then ah is a times the cosine of theta x, and a times the sine theta is a v. So again, this should be straightforward, really. Kind of just wanted to introduce you to a little bit of what we're going to be doing as far as the AutoCAD is concerned, as well as this trig cheat sheet, and then giving you guys some practice problems so you can refamiliarize yourselves with vectors after a long summer. All right.